Hello, everyone. I'm just going to give you guys a few seconds to connect to audio so you can hear the lovely event we have for you guys tonight. I'm just going to give it a few more seconds while all of you join and connect. Okay. Welcome, and thank you so much for joining us tonight. BookHampton, as well as our co-hosts, the Hampton's Observatory, are so excited to present Dr. Avi Loeb in conversation with Dava Sobel for Avi's book, Extraterrestrial, the First Sight of Intelligent Life Beyond Earth. Please send questions at any point using webinar's Q&A feature, which you can access at the bottom of your Zoom screen. We will get to as many questions as possible duration of the event, so thank you in advance and send your questions there. Please also consider purchasing your copy of the book, Extraterrestrial, the First Sign of Intelligent Life Beyond Earth from BookHampton, or a choose your own price ticket of any amount. Your support greatly benefits our ability to continue providing engaging, informative, and entertaining events for readers of all ages, and links will be sent to you via the chat box. I also do want to mention our co-host, the Hampton's Observatory, is having their next event on May 23rd at 7 p.m. And this is by the News 12 meteorologist, John Rayo. So you can find out about that on their website. Links will be sent in the chat box as well. And I'm now just going to share a little bit about our guests of honor before they take it away. Oh, sorry. Just have to find it quickly. I don't have it pulled up here. So sorry. Okay. Dava Sobel, an East Hampton resident, is a high acclaimed, award-winning author of 6 books, including bestsellers, The Glass Universe, How the Ladies of Harvard University Took the Measure of the Stars, Longitude, and The Planets. Dava was a 2000 Pulitzer finalist for her book, Galileo's Daughter, which served as the basis for an Emmy Award-winning PBS documentary. She is currently poetry editor of Scientific American and formerly a science reporter for the New York Times. She has been a member of Hampton Observatory's advisory board since its inception. And I'm now going to pass things off to Dava so she can introduce our guest of honor.
Hi, everyone. I'm Dava Sobel. I'm a member of the advisory board of the Hampton's Observatory and very pleased to be the one introducing our distinguished guest tonight, Dr. Avi Loeb. Just a quick note about the Hampton's Observatory. So we are a nonprofit organization. We've been around since 2005, and we are in the business of encouraging people to be interested in science, especially astronomy. And especially this week, because this is International Dark Sky Week. And we are very fortunate here in East Hampton to have a live view of the Milky Way and to have a town governance that respects that privilege and hopes to preserve it and has issued a resolution about International Dark Sky Week, encouraging residents to turn off the outdoor lights and look up. But not tonight, because it's raining. And besides, we have a wonderful speaker to keep you all indoors. We are also extremely fortunate in East Hampton to have a wonderful independent bookstore, BookHampton, our co-host for tonight. And we are very grateful for their support in this event. So our guest is astrophysicist Dr. Abraham, better known as Avi Loeb, and he holds the Frank B. Baird Jr. Professorship at Harvard and directs the Institute for Theory and Computation within the Harvard-Smithsonian Center for Astrophysics. He is also a best-selling author, and deservedly so. I have read his book, Extraterrestrial, and other books as well, and I heartily recommend it. As will become clear tonight, I'm certain, Dr. Loeb is a person of boundless curiosity and sincere devotion to scientific investigation. He has a lifelong interest in philosophy and almost chose that path for his professional career, but we are happy that he turned to physics and later to astronomy. Among his many truly stellar achievements are nearly 1,000 articles in the professional literature. He was the founding director of the Black Hole Initiative at Harvard and now heads the recently established Galileo Project. So, like all of you, I am very eager to hear what he has to say. Avi Loeb, welcome to the Hamptons Observatory.
Thank you so much, Dava. It's a great honor for me to follow your early remarks because my predecessor at Harvard, that was also the department chair, Cecilia Payne-Koposhkin, was the subject of your book, and her accomplishments are far more important than mine. We both, she lived in the same town that I live in, Lexington, Massachusetts, and she was the first woman department chair of the Department of Astronomy. She got her first PhD in astronomy and at Harvard, and I'm at awe as to her many accomplishments, and it's a privilege for me to follow on your words and describe the very little that I learned over the past few years. And so let me share my screen, and I will go over a set of slides that will illustrate more details on what I've been doing over the past few years. So the focus of my presentation is on a book that I wrote a year ago, published, called The Extraterrestrial. And if I had to summarize it, you see it in the middle of this slide. If I had to summarize it, I would say, when you're not ready to find exceptional things, you will never discover them. And Dava could have saved a lot of time if she would have introduced me as a farm boy. That's what I am fundamentally. All the titles that I acquired in academia at Harvard are not so meaningful to me. I'm basically driven by curiosity and follow my childhood interest in solving problems on my own. The most vivid memory I have from childhood is asking a difficult question at the dinner table, and the adults in the room would dismiss this question because they didn't know the answer to it. And science offers an opportunity for me to figure out the answers myself. What you see on the right side is the cover of another book that I published last year. It's actually a textbook called Life in the Cosmos by Harvard University Press. And it's intended for scientists who are interested in finding whether there is either primitive life in the form of microbes on other planets through their biosignatures, or advanced civilizations through their technosignatures. And what you see on the left side of this slide is a photograph of a picture that was hung on the walls of the Berlin-Brandenburg Academy of Science and Humanities. It was taken by the German photographer Herlinde Quilbel, who came to my office and asked me to write on the palm of my hand the question that I regard as most fundamental in science. And I wrote, "Are we alone?" Now, the way I would like to address this question is using the scientific method. And let me illustrate this method by an example. we don't know. It's really embarrassing to admit that, but after a century of studying the universe, we still don't know what most of the matter in the universe is. It's not ordinary matter of the type that we are made of, and that the Earth is made of, and that the sun is made of. Actually, Cecilia Payne-Koposchkin found that the sun is mostly hydrogen. It's not made of the same stuff as the Earth. But most of the matter, there is 6 times more matter than visible matter that we are familiar with. What is it? We don't know. And it's rather embarrassing because in 1933, Fritz Zwicky discovered it. And since then, we haven't figured it out. And it's surprising that cosmologists are getting paid, even though they don't know what they're talking about. Now, the most popular view of the dark matter in terms of its properties is that it was rather cold when the first objects and galaxies started to form out of it. And by the way, we wouldn't exist without dark matter, because galaxies like the Milky Way would never form if there was only ordinary matter, because there were no seeds of fluctuations for ordinary matter on the scale of the Milky Way galaxy. They would have been washed out by the cosmic background radiation early on. So the only reason we exist is that there is dark matter, and still we don't know what it is. But this picture of the dark matter being cold, the so-called cold dark matter, is being challenged by data. When we look at small galaxies, we would have expected that all galaxies would have a divergence in the density of matter at their center, because the dark matter is cold, so it condenses to the centers of galaxies and creates a cusp in the density. But we don't see that in dwarf galaxies, in small galaxies. And moreover, the abundance of dwarf galaxies is smaller than expected. And so I proposed last month a way to resolve this problem. I wrote a paper saying that maybe the dark matter is organized into clumps, each of them weighing about 10,000 times the sun's mass. And when these clumps scatter off each other, they smooth out the cusp that you expect to find at the centers of dwarf galaxies. But when you consider much bigger systems, then the scattering is much less effective, actually, the gravitational scattering between the clumps. So the problem is resolved for small galaxies, and it doesn't exist for large galaxies or clusters of galaxies. And I suggested that, and within a few hours after my paper was posted on the internet, a professor from the University of Toronto sent me an email and said, I have a way of ruling out your model. Okay, that's just a month ago. And he said, within a year, I'll have data that I'm analyzing that will be able to rule out your model. And you might think, oh, that's threatening. But in fact, I was very pleased by his message, because the data will show whatever reality is. And, you know, if it rules out my suggestion, so be it, then I can move on to other possibilities. But if it ends up proving my suggestion, then that would be very exciting. And that's the scientific method. There is an anomaly, meaning a deviation from what we expect. Some proposals are made to explain it. And then you do the experiment. You look for evidence that either rules them in or rules them out. And that's the scientific process. So the idea is not to be guided by prejudice, but be guided by evidence. And what did the scientific method teach us so far about the universe? The most important lesson, and you wouldn't hear it from many astronomers, but that's the lesson that I learned throughout the past 4 decades, is that nature gives us a simple message: be modest. Okay, and why do I say that? Because the ancient Greek philosopher Aristotle argued that we are at the center of the universe, and people believed him for 1,000 years because it flattered their ego. And then Galileo Galilei and Copernicus, they argued that no, it looks to them as if perhaps the Earth moves around the sun, so it's not at the center of the universe. And of course, the philosophers at the time didn't like it for religious reasons, and they put Galileo in house arrest. Today, they would have canceled him on social media. But if you were to ask those philosophers to design a mission to reach Mars, they will never get to their destination, because they thought that Mars moves around the Earth. So my point is, reality is whatever it is. And we can live in a virtual reality that flatters our ego, just like putting makeup. But I prefer to see the pimples on the face of reality because that's our only chance to adapt to it. And beyond the fact that we are not at the center of the universe, we now know that about half of the sun-like stars have a planet the size of the Earth, roughly at the same separation. So not only we are not at the center of the stage, of the cosmic stage, but what we find in our backyard is not unique or privileged. That message comes back to us again and again. We should have modesty. And when you look at emperors or kings that were very proud of themselves after conquering a piece of land, and in today's newspapers, it's Putin trying to conquer a piece of Ukraine, that's not very impressive because there are more habitable Earths in the observable volume of the universe than there are grains of sand on all beaches on Earth. So such an emperor is not more impressive than an ant hugging a single grain of sand on the landscape of a huge beach. But I can understand where it's coming from because when I looked at my daughters when they were young, they stayed at home and they thought that they're the smartest in the world just because they compare themselves to the family members. And that perception changed when we took them to the kindergarten and they met other kids. They realized there is a smarter kid on our block. So our civilization will mature by finding others. And my point is that Albert Einstein was not necessarily the smartest scientist who ever lived since the Big Bang, 13.8 billion years ago. You can see here a cartoon that was drawn on the day that Einstein died, and it shows a plaque on Earth. Albert Einstein lived here, as if humanity is identified by his existence. But my point is, there were probably smarter scientists on a habitable planet around another star that predated Einstein by 1 billion years. And the civilization that hosted these scientists benefited from their wisdom and had enough time in 1 billion years to launch probes that would fill the entire Milky Way galaxy by now, including the solar system. Because most stars formed billions of years before the sun. We know that. We observe the star formation history of the universe. And sending humans to space is not necessarily the best path forward for us. And we have artificial intelligence systems driving cars. And in the future, I can imagine sending AI astronauts, meaning autonomous systems made of equipment that can function without guidance from us. And that's the way to go because the distances between stars are so huge that equipment cannot wait for guidance from the senders. It takes light thousands of years to traverse the Milky Way galaxy. Now, these AI astronauts could have traveled across the entire Milky Way galaxy easily within 1 billion years, even if they used chemical propulsion. So the question is whether we live in a reality where probes are all around us or not. This is not a philosophical question. We just need to look through our telescopes to find out the answer. And we don't want to repeat the mistake of philosophers 4 centuries ago who refused to look through Galileo's telescope because they knew the answer. So what do we see when we look through telescopes? So interestingly, only over the past decade, we had a survey telescope that could detect the reflected sunlight from an object the size of a football field that passes within the orbit of the Earth around the sun. Only over the past decade. We couldn't see objects of that size before that. And keep in mind that NASA never sent a spacecraft as big as a football field. And in 2017, on October 19th, that telescope, Pan-STARRS, on the summit of Haleakala in Maui, Hawaii, discovered the first object from outside the solar system. It was given the name Oumuamua, which means a scout in the Hawaiian language. It was the first reported interstellar object the size of a football field, about 100 to 200 meters in size. You can see it circled in blue. But this was not the first interstellar object discovered, as it turns out. There was another one discovered in 2014, in January, about nearly 4 years before Oumuamua. And the way we realized it with my student, Amir Siraj, is because I was interviewed for a radio station about some meteor, and I wanted to learn more about meteors. So I went online and I found a catalog of meteor data that the government released. And I asked my student to check if the fastest moving meteors could have been unbound to the sun. It's a very simple calculation. We know the velocity of these meteors when they enter the Earth's atmosphere and start to burn up. And we can go back in time and ask whether they were bound to the sun, subtracting off the motion of the Earth from their relative speed. And he looked at the fastest object and realized that it was a head-on collision with the Earth. It was moving exactly opposite to the Earth's motion. The second fastest was actually unbound to the sun. And then we wrote a scientific paper saying the US government data, which is primarily satellite data and audio sensors data, and this system that the government owns is much better equipped than any astronomical observatory because it's funded at a much higher level to be a warning system for missiles, for ballistic missiles. And so we wrote this paper saying here is an interstellar meteor that came from outside the solar system because we calculated that it moved at a speed of 60 kilometers per second outside the solar system. That's twice as fast as nearby stars are moving. So it was really moving fast. And the referee of the paper rejected it. He said, we don't believe the US government data. They didn't give us the uncertainties. And I thought to myself, well, they probably need to know whether a missile will hit Boston versus New York City. So I trust the US government when it talks about objects entering the atmosphere. Nevertheless, the paper was not published in 2019 when we announced it. And then through my connections, I chaired the board on physics and astronomy of the National Academies. I was able to motivate some people within government to put out a letter that came out just last month. You can see it on the left here from the United States Space Command at the Department of Defense. Very unusual letter sent to NASA and testifying that the paper that we wrote with my student, Amir Siraj, and myself, they promoted him to a doctor. He's still finishing his master's now. That paper is correct, that this meteor is indeed unbound to the sun at the 99.999% confidence. And moreover, they released the light curve of the fireball when the object burned up in the Earth's atmosphere. This object released about 2% of the Hiroshima bomb energy when it burned up, and it was roughly 0.5 meter in size. And there should be roughly 1 million such objects within the orbit of the Earth around the sun at any given time. It's just that the Earth is like a fishing net, collecting such objects once every few years. And this is the light curve from the fireball of this object that the government released. And the amount of power that you see here, up to 4 terawatt, is a quarter of the world's consumption of energy. That's quite remarkable. What we found is that the flares from the burnup of this object occurred very low in the atmosphere at a height of about 20 kilometers. And in order for the object to survive down to the lowest levels of the atmosphere, it had to be very strong in terms of its material strength. In fact, twice as strong as iron. And only 5%, a 20th of all the meteors that we find from the solar system are made of iron. 95% are made of rock. They are called stony meteorite. And they are 20 times less strong than this object was. So not only that the object, the first interstellar meteor, was unusual in terms of its speed, being larger than 95% of all the stars in the vicinity of the sun, but its composition was tougher than iron by a factor of 2. And just before this presentation, I sent some background materials to the Prime Minister of Papua New Guinea, because this meteor fell off the coast of Papua New Guinea near Manus Island. And we need the authorization to scoop the ocean floor for meteor fragments from that fireball. And we're planning to do this expedition. We have already a ship led by the person who went after the Titanic. These are all developments from the past week, so you have a scoop here. And we are planning to go to near Papua New Guinea towards the end of 2023, scoop the ocean floor with a magnet and collect the fragments of this meteor. And that's not a very expensive mission. It's roughly $500,000 in price compared to $1 billion to search for the material making an object in space, like Oumuamua. So we will have our hands on the material of this object, hopefully within a year and a half, and then we can examine them. We can figure out what the composition of this object was and whether it was natural or artificial in origin. But let me go back to Oumuamua, which was the first reported interstellar object. And it was also quite unusual and weird. In fact, one of my colleagues said after a colloquium about this object, Oumuamua is so weird, I wish it never existed, which is pretty much the attitude of experts that want to explain everything they find in terms of their past knowledge, and they feel threatened by something that looks unusual. But to me, it's actually exciting. It's an opportunity to learn something new. Nature is telling us that we don't fully understand it. So one of the anomalies of Oumuamua was that it came from a special frame of reference. It's called the local standard of rest. It's the frame that you get to when you average over the motions of all the stars in the vicinity of the sun. And this object, Oumuamua, was at rest in that frame. Only 1 in 500 stars is so much at rest as Oumuamua was when it entered the solar system. So that makes it quite unusual if it came from a star system. And then as it came close to the sun gave it a gravitational kick, just like a racket giving a tennis ball a kick in a different direction. And as the object was tumbling every 8 hours, the amount of sunlight that was reflected from it changed by a factor of 10. And that meant that the object has an extreme shape, just like a piece of paper tumbling in the wind. When trying to fit the variation of reflected sunlight, the best shape that was inferred at the 90% confidence is that of a pancake, a disc-like shape, much more likely than a cigar shape. But that was not the only unusual property of this object. The Spitzer Space Telescope tried to look for any carbon-based molecules in the vicinity of the object, and we find lots of those near comets. At first, astronomers thought it must be a comet. These are the most common objects in the outskirts of the solar system. So if the object was lost from another star, then it was most likely to be a comet, meaning a rock covered with ice. And when such a rock gets close to the sun, the ice evaporates and you see a cometary tail. But you can see the image from the Spitzer Space Telescope on the top right, and it's basically just noise. There was nothing detected. There was a very tight limit that the Spitzer data put on evaporation of this object. It was definitely not a comet of the type that we had seen in the solar system. So then astronomers said, okay, so maybe it's just a rock without any ice. But surprisingly, the object was pushed away from the sun by some mysterious force. And I say mysterious because without the rocket effect of evaporation, what else is there to push it? And the only explanation that I could think of is the reflection of sunlight, because this force declined inversely with distance squared, just like you expect for the reflection of sunlight pushing an object. But for that to be effective, the object had to be very thin, sort of like a sail. And nature doesn't make thin, flat objects. So I suggested maybe it's artificial in origin. It could be a leaflet. It could be the surface layer of a spacecraft that another civilization manufactured. And I suggested that just because it had to be considered given the anomalies of Oumuamua that I mentioned. Now, of course, there was a lot of pushback from the mainstream of astronomy. Nobody wanted to hear that. The experts argue that anything we see on the sky must be a rock, because that's the foundation for their knowledge base. That's what we have seen from the solar system before. And it reminded me of, there was a group of experts that wrote a review article in Nature Astronomy magazine saying this object, Oumuamua, must be natural, period. And it reminded me of a book that was written back in the 1930s about Einstein's theory of relativity. 100 authors against Einstein's theory of relativity. And when Albert Einstein was asked about this book, he said, why do you need 100 authors? It's sufficient to have one that makes a good argument. And I felt exactly the same, because a few months after this review paper was written that the object must be natural, one team wrote a paper saying, well, maybe it's a dust cloud that is 100 times less dense than air, and then it's being pushed by reflection of sunlight. And the problem of that is that it wouldn't survive coming close to the sun, because it wouldn't maintain its integrity when it's heated by hundreds of degrees. So then a few months later, another team of mainstream astronomers suggested, well, maybe it's a chunk of frozen hydrogen. So it's actually a comet, but the cometary tail is transparent because it's made of hydrogen. And the problem with that suggestion is that such an iceberg would get evaporated along its journey in interstellar space very quickly as a result of absorbing starlight. So then finally, another team said, well, it's not a hydrogen iceberg, but it's a nitrogen iceberg. We found it. It's a chunk of frozen nitrogen that was chipped off the surface of a planet like Pluto. And then everyone cheered and said, yeah, that's why it's natural, because now it's nitrogen. And I say, look, all of these objects that you suggested, were never seen before. And if we have to imagine things that we've never seen before, we better leave on the table the possibility that it's artificial as well. The fundamental question is whether Oumuamua was natural or artificial in origin. And we should contemplate both possibilities when we collect more data, because that would motivate us to get more data. And the way I think of this is just like walking on the beach. Most of the time you see seashells or rocks that were naturally produced, but every now and then you find a plastic bottle. And perhaps Oumuamua was a plastic bottle, indicating that a civilization is out there. And keep in mind, it was the first reported interstellar object. Now, in September 2020, there was another object discovered by Pan-STARRS, the same survey telescope that found the Oumuamua. And this one was given the name 2020 SO. It shared the same qualities as Oumuamua. It was pushed away from the sun by reflecting sunlight, no cometary tail. And then a few weeks later, the astronomers realized it actually came from Earth. It was a rocket booster that was launched in 1966 as part of a lunar lander mission. And we know why it was pushed away from the sun by reflecting sunlight, because it had thin walls. It was not designed to be a light sail. So we know that this object, 2020 SO, was artificial because we made it. The question is, who made Oumuamua? And the way I think of this is like a cave dweller finding a cell phone. The cave dweller is used to playing with rocks all of his life. So he would argue that the cell phone is a rock of a type that he had never seen before. And if he's not curious, he will simply throw it away, come back to his family, and report that he had found a rock of a type that he had never seen before. Just like some astronomers would argue, Oumuamua is a rock of a type that we've never seen before. But if this cave dweller is curious, he might press a button and realize that this object records his voice and therefore is not a rock. I would love to press a button on a technological object from another civilization. Now, this opens up the door for a completely different mode of search for technological signatures. It's not radio signals the way they were advocated for 70 years. That requires a partner that transmits when you are listening, sort of like a phone conversation. Here, we're talking about an object, and the sender may not be alive when we find it. So it resembles archaeology. I call it extraterrestrial archaeology. And instead of the Drake equation, which is used for radio signals, assessing the chance that we would find one, here the calculation is much simpler. The number of interstellar objects like Oumuamua that we find in a survey of a given volume simply depends on the number of objects per unit volume. That's all in our vicinity. And that number keeps accumulating over time, just like plastic bottles on the beach, if nobody cleans them. There is another approach, which is using the Earth as a fishing net to capture interstellar meteors. And here you depend, the number of such objects found depends on their number per unit volume times their characteristic speed, because that would provide the number of objects intercepting the surface of the Earth per unit time. And both the number of objects and their speed might depend on size. There may be many more small objects than big objects. But these equations must be supplemented by an additional factor, which I call the ostrich factor. What do I mean by that? It's the likelihood that we will behave like ostriches and not search. So if we don't search, we will not find anything. The likelihood of discovery depends also on us, not just on them. And currently we have a rover on the surface of Mars. It's actually a robot. It's not an AI astronaut because it's operated by engineers in Pasadena. And the goal is to find whether early Mars had life on it in the form of microbes. That doesn't threaten our ego because humans are much more intelligent than microbes. So if we find microbes, everyone would be happy. But imagine a situation where the same rover will bump into the wreckage of an advanced spacecraft that represents a technology that we don't possess. That would be a blow to our ego. So many people would prefer not to find it. And, it's really not a philosophical question because a picture is worth 1,000 words. In my case, a picture is worth 66,000 words, the number of words in my book. I wouldn't need to write the book if we had a picture of Oumuamua, for example. And what you see on the right side is a photograph of the asteroid Bennu that was taken by the OSIRIS-REx mission that landed on its surface, and you can clearly see that it's a rock. So if we were to land on Oumuamua and we would find nitrogen, we would know it's a nitrogen iceberg. But on the other hand, we could find that it has bolts and screws on it, and there is a label saying made on exoplanet Y. And that would be enough for me. I will not need to convince anyone. When looking at this image, it will be obvious that it's a piece of technology and not a rock. So all we need is good evidence, and that was the basis for founding the Galileo Project last year. And one of the goals of the Galileo Project is to date the next Oumuamua, because by now Oumuamua is very far away. It's 1 million times fainter than it was close to us. We can't really chase it. It's moving too fast. So we better find another one. It's sort of like going on a date and liking a person, but then by the time you realize it, the person left the restaurant and you can't really find it, that person. And so what you want to do is date the next one that looks just like it. And the way to do it is to use the forthcoming Vera Rubin Observatory that will start operations in Chile within a year. It will have the Legacy Survey of Space and Time, LSST, that could identify interstellar objects like Oumuamua every few months. And what one should look for is objects that do not resemble asteroids or comets that belong to the solar system. And of course, this telescope will have unprecedented resolution. It will provide a video of the sky with a 3.2 billion pixel camera. That's remarkable. And the way I think of this telescope is like a dating app. Most of the time we will swipe to the left because the date in this case would cost $1 billion. We are working on the design of the space mission. It will be very expensive. So when you go on $1 billion date, you have to be quite careful as to whom you're dating. You can't just spend $1 billion on many space rocks. You have to find the one that looks most unusual. And in fact, that is the basis for an NFT project that I'm also involved in. So in addition to coming close to Oumuamua and taking a close-up photograph of it, one can observe the next Oumuamua with, for example, the James Webb Space Telescope. And the Webb telescope is 1.5 million kilometers away from Earth. So if an object comes along, we will see it from two different directions, from the Earth and from the Lagrange point 2, where the Webb telescope is located. And that will allow us to view its trajectory in 3 dimensions using parallax. So in fact, we will be able to tell to exquisite precision whether there are forces acting on the object in addition to the sun's gravity. And moreover, the James Webb Space Telescope could take a spectrum. It's a 6.5 meter telescope that we didn't have when we discovered the Oumuamua. And so it could give us information about the composition of the object from the reflected spectrum, from the emitted spectrum, and so forth. And one possibility is that Oumuamua was thin and flat because it was a leaflet carrying a message. And it would be tragic if you miss a love letter in our mailbox, because as a civilization, we would expire one day if we destroy our climate or perish in a war. And so we better find the message that could help us survive if someone else figured it out. And when I go to Harvard Square, I very often find statues or paintings of past presidents and deans that wanted to maintain their physical appearance for future generations to see, because they were very proud of themselves. But if you think about it, that's not the best way to preserve your memory, because in less than 1 billion years, the sun will expand and burn up the surface of the earth, all the oceans, everything, and nothing will survive. So a much better approach is to send a monument to space. If you send an AI astronaut that carries the flame of your consciousness and follows your guiding principles, sort of like sending a technological kid to space, that kid could outlast the sun. So it makes much more sense to send AI astronauts as monuments than to build a statue or paint a picture of yourself. And I should say that there is an embarrassing fact about what we sent to space so far. It's the New Horizons spacecraft that was sent to Pluto by NASA, and it carried a box with 30 grams of the ashes of the scientist who discovered Pluto, Clyde Tombaugh. And imagine an extraterrestrial finding this box. They would be quite surprised and say that humans have this very primitive ritual of burning up the genetic information on a person whom they wish to commemorate. That makes very little sense, and they would want to have nothing with human civilization, and because of this rather primitive and not intelligent approach. And just to think about the fact that this spacecraft was supposed to carry our pride to outside the solar system. So my point is we should probably launch a faster spacecraft that will overtake New Horizons and apologize for the content of this box, because the ashes of Tombaugh are no different than the ashes of a cigarette. And if we wanted to actually commemorate him, we would have put an electronic version of his DNA or a stem cell from his body. This way, the extraterrestrials would have been able to reconstruct Tombaugh. Now, in June 2021, the Director of National Intelligence, Avril Haines, submitted a report to the US Congress talking about objects that the government cannot identify. Their nature is unclear. They call them unidentified aerial phenomena, UAP. And as a result of that, a year later, in June this year, 2022, there will be a new office that will start operations. It was signed into law by President Biden, and it will basically coordinate the assembly of data on these objects from all branches of government that usually don't speak to each other. And the head of NASA, Bill Nelson, said that he saw the classified version of this data, and he thinks that it's quite serious and that the scientific community needs to get on the task of figuring out the nature of these objects. So that was the second reason for establishing the Galileo Project, helping the government to figure out the nature of these objects, whose nature is unclear. And obviously, if the government suspected that these objects belong to another nation, that would be a matter of national security. They wouldn't admit it publicly. It seems like the data is puzzling. So we would like to construct new telescope systems that would give us fresh data, because the sky is not classified. We can figure it out. And extraordinary conservatism leads to extraordinary ignorance. And, you know, if we find that all these objects can be explained as human-made or natural, so be it. We will clear up the fog and move to other problems. By now, we have more than 100 people engaged in the Galileo Project. The funding for the project originated from private donations, a few multi-billionaires who visited the porch of my home after reading my book, Extraterrestrial, and they donated $2 million to my research funds at Harvard. And what we need to accomplish the task is more like $100 million. And I'm working on trying to get to that goal. So the Galileo Project has two objectives. One, to figure out the nature of these objects that the government cannot figure out. And then the second is to take a high-resolution image of the next Oumuamua. And we're currently engaged in the design of this space mission together with the Southwest Research Institute that decided to allocate almost $300,000 to this mission study. And within the coming months, we plan to establish telescopes, the first telescope system on the roof of the Harvard College Observatory to look at UAP. And it includes an infrared camera, visible light camera that looks at the entire sky at all times, an audio system and a radar system that monitor the sky, and the data will be fed to a computer system that will use artificial intelligence to figure out the nature of objects that we see. So this is the infrared and visible light cameras that take a video of the sky at all times. And people often say to me, my colleagues say, extraordinary claims require extraordinary evidence, which is a quote from Carl Sagan. And I disagree with that. First of all, it's sufficient to have evidence, you know, that's the first step. But my point is, extraordinary evidence requires extraordinary funding. So let me illustrate that with an example. The Large Hadron Collider at CERN was motivated at a cost of about $10 billion to perhaps discover the particle that makes the dark matter. It was thought to be the lightest supersymmetric particle, and it was worth $10 billion to search for it. We invested that money, we haven't found it. You could have argued the lightest supersymmetric particle is an extraordinary claim. I don't want to discuss it until we see evidence for it. But that's not the way science works. If there is an interesting possibility that results from anomalies that we see, then we invest billions of dollars in trying to figure out what it means. And, you know, if we search for technological equipment from other civilizations, just because we sent equipment to space, and we know now that there are billions of planets that have conditions similar to Earth around other stars, and they predated the Earth by billions of years. So if we search for things that we sent out, just to check, you know, and we invest billions of dollars in that search for 40 years, and we don't find anything, then we will be exactly at the same point as dark matter searches are right now. And dark matter searches are part of the mainstream in physics, in astronomy. And so how is it possible that a subject that the public is so interested in, the existence of extraterrestrial technological civilizations, the fact that we have some anomalies that need explanations, and the fact that we have the ability to search for such objects for the first time in human history, how is it possible that the mainstream of academia has a problem with that and ridicules it and doesn't pursue it? It's exactly 180 degrees of where it should be. Of course, we can look remotely for industrial pollution in the atmospheres of planets, or city lights on the night side of planets. And I wrote papers on those kind of searches. But we have to recognize that there is a tension between the ability of a technological civilization to destroy itself and its ability to venture into space. So if it doesn't send anything to space before it destroys itself, then within 1 billion years afterwards, there would be no trace of that technological civilizations. Any computer terminals that you have on the surface of Earth will be mixed with the Earth interior through geological activities within 1 billion years. So the only way to leave monuments, as I argued before, is to send equipment to space. And of course, we should search for such things from other civilizations. There is this famous paradox from a statement that Enrico Fermi, a famous physicist, made during lunchtime in Los Alamos 70 years ago. He said, if extraterrestrials are out there, where is everybody? Now, this is a very presumptuous statement. Again, I disagree with it, because it's just like sitting at home and saying, I don't have neighbors because nobody is knocking on my door or nobody is sitting in front of me. And of course, most of the time, your neighbors are not knocking on your door. You have to look through the windows, and you better use a telescope to find them. And it's also possible that our neighbors existed and they are dead by now because they destroy themselves the way we do. So there are two types of technological equipment that we may find. There could be space trash, just like New Horizons will be in 1 billion years. And there could be equipment that is operational, AI astronauts trying to seek some information. And by the way, for the second class, we don't have a protocol of engagement because it's very urgent to respond to such an object that is operational. It's quite different from getting a radio signal from a star that is thousands of light years away. There is no urgency in responding to that message. But if you have a visitor in your backyard, you better do something about it. And the question is, we don't have an organization that represents us. So who represents Earth? And even if there was such an organization, I'm sure that some people will act on their own and could endanger the rest of humanity if they do the wrong thing. And moreover, any such object may represent technologies that are far more advanced than we possess, because we developed our technologies only over the past century. And imagine what we will have in 1 million years from now. So if there is another civilization that sent equipment far more advanced than we possess, we will never understand it. We will not be able to figure out what its intent is. And a very advanced scientific civilization would be a good approximation to what religious texts called God, because in principle, they could have created synthetic life in their laboratories, could have created baby universes in their laboratories. These are qualities that we assign to God. And the encounter, in principle, could give us a meaning to our life, because just imagine if our life on Earth was seeded by another civilization, we would feel like orphans that realize something new about their lost parents. And obviously, we need to search in order to find that evidence. My hope is that by finding a smarter kid on our block, we would be inspired, because if you look at human history, most of it was shaped by a group of people trying to feel superior relative to other people. The best example is the Nazi regime that triggered the death of 75 million people during World War II. And that was 3% of the world population in 1940, 5 times more than the number of deaths triggered by COVID-19, just because a group of people decided to feel superior. So if we find a smarter kid on our block, perhaps it will convince us that the differences among humans are meaningless. And in fact, we should treat each other as equal members of the human species. Because the play is not about us. We are not at the center of the stage. We just came relatively late. The universe existed for 13.8 billion years before us. So if you arrive to a play towards the end, it's not about you. And, we just developed our cultural habits. The recorded human history is only 10,000 years old. That's 1/1,000,000th of the cosmic history. And many civilizations could have appeared and disappeared before we developed our modern telescope technologies to detect them. And my advice to humanity is to search for other actors, because they may know more about this play. Thank you.
Okay, so we do have a few questions from the audience. I just want to make sure that it's okay with you both that we answer those. I know we're a little bit over 8 o'clock, and I just want to make sure that you guys have time for some questions.
Definitely. Yeah.
Okay, so we will get a few in here. Let's see. Was it possible to detect any signal transmission from Oumuamua either towards Earth or towards another star?
Yeah, so in fact, when the object was discovered and looked a bit weird, I immediately approached colleagues that have access to radio telescopes, and we checked, and we got a limit of less than 1/10 of the transmission of a cell phone coming from it. But obviously, you know, even if it was functional and was collecting information about the inner solar system, you know, there is no reason why it would transmit at the frequencies that we were looking at the time that we were looking at, and in our direction. So it's really, you know, and it most likely, you know, it could have been space trash. You know, we don't know what it was. So the key to answering such questions is to get better data on the next object that looks weird. And, you know, we were not prepared for that. For me, it was a wake-up call.
Okay. So our next question, this is kind of a long one, so bear with me here. There was an article entitled "The Natural History of Oumuamua" published in 2019 in an issue of Nature, where the author stated, "In all cases, the observations are consistent with a purely natural origin for Oumuamua. We discuss how the observed character explained by our extensive knowledge of natural minor bodies in our solar system and our current knowledge of the evolution of planetary systems." And then you had claimed in your book that Oumuamua was an artifact of an extraterrestrial technology. Do you think that the researchers who published a Nature article were mistaken? If so, where did they go wrong?
Okay, well, I actually mentioned it in my presentation. I talked about the review article that was published in Nature Astronomy magazine. So I actually explicitly discussed this paper, and I said that this paper appeared before the 4 other papers that tried to explain Oumuamua appeared. So if it was obvious, forget about me. If it was obvious to the community, as the experts were claiming, that this object is natural, why did the other groups invested months of their time in publishing research papers suggesting a hydrogen iceberg, a nitrogen iceberg, or a dust bunny to explain this object, right? All of these involved objects of a type that we've never seen before to explain the anomalies of Oumuamua. And all of them were published after the review paper claimed it must be natural, period. So I rest my case. If it was obvious, these papers would not have been published, right? And the fact that they were published talking about things that we've never seen before implies that the object was weird.
Okay. If an extraterrestrial technological object was recovered on Earth, it seems militaries, say the US military, for example, would have a vested interest in recovering such an object and keeping it a secret. There are many claims that this has already occurred. How would you explain the possibility that this may have happened?
Right. So, you know, I don't believe in conspiracies because I don't think the government is competent enough to hide them. And my take is, just like a kid, if you want to think about the way I think, the way I approach science, just think of a kid, okay? I don't want to listen to what other people say. I want to figure it out for myself. Science is about reproducibility of results. You know, if there is evidence for objects in the sky that are unusual, we can see them, okay, with telescopes. Let's just, now, astronomical telescopes in the past would never pay attention to these objects because if a bird flies above an observatory, it would be ignored. The astronomers would not monitor it. Astronomers focus on very distant sources of light. And actually, Harvard University, you know, the administration asked me when I established the Galileo Project, they asked me, is this part of your day job? And I said, after thinking about it, I said, yes, I think it's part of my day job because for 4 decades, I've been analyzing data collected by telescopes and explaining it, trying to interpret it. That was my day job. And we are planning within the Galileo Project to collect data with telescopes and interpret it. Now, in astronomy, there is no minimum distance to an object of interest. We look at the sun, we look at meteors, we look at asteroids. and that these are all part of astronomy. So what I'm doing within the Galileo Project is part of my day job, and they accepted that.
Okay. What will be the maximum viewing distance of the Galileo telescopes used for UAP research?
Right. So there are two aspects that affect the answer to this question. One is the opacity of the atmosphere. The atmosphere doesn't allow you to see beyond a distance of about 10 kilometers because of the absorption of visible light in the atmosphere. And so we can't see more than about 10 kilometers, depending, of course, on the direction we're looking and the conditions during, in terms of weather and so forth. But there is another constraint which has to do with being able to resolve an object. And so that depends on the size of the telescope you're using and also the turbulence in the atmosphere. And if you're not correcting for the turbulence in the atmosphere, which will cost a lot of money to correct for, it's called adaptive optics. If you don't do that, if you don't, when there is turbulence, you don't compensate for it, then you are limited again to that kind of a distance in terms of resolving objects of interest, the size of a person. So we're talking about, several miles to up to 5 miles in distance. And that's why we need a network of telescope systems in many different locations. We estimated about hundreds of those, and that would cost $100 million. That's why I need to fundraise to a level of 100 million. The 2 million that we have will allow us to demonstrate that we know what we are doing, and that we will do in the coming months. And we will build a few such systems, make the first one at the Harvard College Observatory, and make a few copies of it and put them in various locations to collect data. And the other thing that we will be doing is this expedition to Papua New Guinea. And it turns out, here is an interesting point. I just spoke with a person who lives in Papua New Guinea a couple of hours ago. And I sent him materials that he will bring to the attention of the Prime Minister, because it turns out that Papua New Guinea is under British law. It used to be occupied by the Brits, but even when it gained independence, it maintained the same laws. And the British Empire had a law that anything within 200 miles of the coast of Papua New Guinea is their property, okay? Because there were ships carrying gold that were sunk, and they wanted to keep that property. And so the law was preserved. We have to get the permission to scoop the ocean floor for fragments of this meteor, which requires a parliamentary approval, and I very much hope we will get that. And we already have a ship, and it will be very exciting towards the end of 2023 to go there. This meteor chose a very beautiful site to land on, and I'm grateful to nature for that.
All right. Well, I think that's all the time we have tonight. I want to thank both Dr. Loeb and Dava Sobel for being here tonight. We so enjoyed having you here. And as always, do not forget to purchase a copy of Extraterrestrial, the First Sign of Intelligent Life Beyond Earth. We do have links in the chat, so you can easily purchase them there. I want to thank everyone for joining us tonight, and thank you again to both of you.
Thank you.